Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today. We spend so much time talking about the magic of artificial intelligence, right? The massive parameter counts, the incredible compute power, those jaw-dropping outputs we see every day. But today, we're actually going to set all of that aside. We're going to dig a lot deeper and look at what actually powers our AI models right beneath the surface. We are looking at the architecture of the data itself. So let's kick things off with a surprisingly fundamental question. What is your data actually made of? I mean, it sounds like a simple question. A lot of us carry around this common assumption that datasets are merely passive collections of files. We kind of picture a giant digital filing cabinet sitting on a server somewhere, just passively waiting to be processed. But what if I told you that assumption is entirely backward? The source material we're exploring today completely flips that narrative on its head, with one absolutely core premise. Data is a chain of decisions. It is not a passive object. It's an active, deeply interconnected chain of human judgments. It's literally alive with the fingerprints of the people who built it. Okay, let's dive into Section 1, Data as Human Decisions. When we stop looking at data as just files and start looking at it as a sequence of human actions, everything changes. Because every single sample represents a choice. Think about it. Just selecting a photo of a red apple to include in a training set means you are actively excluding a green one. You are drawing a line in the sand about what matters to the model and what doesn't. And it goes further than that. Every label represents a judgment. Categorizing data is never entirely objective. When you attach a label to a sample, you're making a highly subjective judgment call based on human perception. You are essentially teaching the machine your specific version of reality, which is shaped entirely by human interpretation. Finally, every validation represents a claim about quality. When someone validates that labeled sample, they aren't just checking a box. They are essentially making a bold claim about its underlying truth. They are planting a flag and saying, yep, this data is correct and ready to teach a machine. Choice, judgment, claim. It's a rapid-fire sequence of intense human actions. And this brilliantly illustrates the massive stakes here. Because data is a chain of human decisions, the outcome of your AI is entirely dependent on their strength. Strong decisions build a stronger model. But if those decisions are weak or flawed, if the judgments are off or the claims are just false, well, you aren't teaching the model. You're actively pumping noise and confusion right into the system. All right, moving to Section 2, the architecture of evidence. So how do we actually fix this noise? To solve it, a platform called Codata.io structures data around what they call atomic contributions. You can think of these like the individual, meticulously inspected Lego bricks of a dataset. Instead of looking at a dataset as one massive, messy blob, they break it down to its very atoms, the absolute smallest indivisible units of contribution. By doing this, they can control the quality of every single decision in the chain. Now, what's really interesting about this side is how Codata.io demands that each atomic contribution hits 4 distinct marks. It must be attributable, verifiable, traceable, and reusable. It's essentially a rigorous background check for your data points. If you know exactly who made the contribution, and you can verify its absolute truth, trace its history, and reliably reuse it, you eradicate those weak decisions that cause system noise in the first place. By rigorously demanding these 4 specific traits, at the atomic level, we achieve something pretty remarkable. We are creating datasets that are far more than mere collections of files. We're transforming a chaotic folder of random digital information into a structurally sound, meticulously engineered foundation for machine learning. We're turning passive files into active, verified truth. Which brings us to Section 3, the formula for better AI. Let's move to this next concept and see how this all builds. When we zoom out from those microscopic atoms, this creates a beautifully elegant chain reaction. Step 1, better contributions, meaning that verifiable, traceable data we just talked about. That naturally leads to Step 2, better datasets built on strong definitive decisions, which inevitably results in Step 3, better AI. When you fix the atoms, you fix the entire universe of the model. And that leads us to a powerful conclusion from our source material. When data is built this way, they become organized systems of evidence. Your AI is literally only as smart as the evidence it's fed. So I want to leave you with this final thought. The next time you look at your AI models, ask yourself, are you training them on a noisy folder of files, or are you fueling them with an undeniable system of evidence? Thanks so much for exploring this with me today. Keep learning, and I'll see you in the next explainer.